All right, here is our third example. This one might not seem like a mixture problem. This is probably the trickiest of all the mixture problems, but I want you to see that it actually is a mixture problem. Cal has a collection of quarters and 50-cent pieces. There are 67 coins in his collection. The face value of the collection is $22.50. How many quarters and how many 50-cent pieces does he have? Now, it probably doesn't seem like this chart will work, but it really will. So let's see what goes where. Okay, I'll have quarters, 50-cent pieces, and then the whole collection. Okay, this part's the hardest part. Why would I have 0.25 and 0.50 under the per column? I want you to think about that for just a second. What is the worth of a quarter? It's just like looking at pounds of M&Ms. You know, a pound of M&Ms was $2.25 per pound. A quarter is worth 0.25 of a dollar per quarter. So my per is just my worth of whatever item that is per item. So my quarters are worth 25 cents each, 25 cents per quarter, or 50 cents per 50-cent piece. Okay, what else do I know? Okay, I don't know how many quarters or 50-cent pieces, but I do know that there are 67 pieces in the collection. So I have X for the number of quarters, Y for the number of 50-cent pieces, and 67 for the total number of coins in the collection. Now, where does $22.50 go? Does it go in my per column? Is there a coin that's worth $22.50 for each coin? No, what is $22.50? Where does that go? $22.50 is the worth of my whole collection. So it goes over under the total column. This is why I said when we first did that M&M example, pay close attention to when it goes in the per column and when it goes in the total column. That $22.50 is not a per. It's a total cost, a total worth of the collection. It's not a cost per coin. All right, why do I have 0.25 times X? What does that represent? That's like the subtotal. That's the subtotal of what the quarters in the collection are worth. And the 0.50 times Y, that's how much the 50-cent pieces are worth. If I take 25 cents per quarter times X quarters, that gives me the worth of the quarters. 0.50 dollars per coin for 50-cent pieces times Y 50-cent pieces gives me 0.50Y, gives me the worth of the 50-cent pieces. So look at the chart, make sure this chart makes sense. Now that we've got the chart, what are my equations? Okay, X plus Y equals 67. Hopefully that one makes good sense. We have the number of quarters plus the number of 50-cent pieces equals the total number of coins in the collection. Okay, next we have 0.25X plus 0.50Y equals 22.50. What's the reasoning behind that? I know you're always taking the middle column and the right column to make your equations, but think about whether or not they really make sense. Yes, the subtotal of what the quarters are worth plus the total of what the 50-cent pieces are worth gives you the worth of the collection, so that one makes sense as well. Solving these, we can do substitution or elimination. They're both equally good. Let's do elimination just to keep things even. So we'd multiply the top equation by negative 0.25. That would enable my x's to cancel. So I'd have positive 0.25y equals 5.75, or y is 23. So I have 23 coins that are 50-cent pieces. Plugging back in, I'd have 44 quarters. So Cal has 44 quarters and 23 half dollars, or 23 50-cent pieces.